Okay. The diagram represents the circular cross-section of an artery with external diameter D of 1.6 centimeters. The thickness T of the artery wall is 1 millimeter. So 1.6 centimeters is 16 millimeters. And we need to calculate the radius of the external circle, which will be 16 by 2, which is 8 millimeters overall. So the radius of the internal circle is 8 minus 1, which is 7 millimeters. And we need to know this to calculate the area of the internal cross-sectional area, which is shaded. So the area's formula is pi r squared, which you should know before the exam. And therefore, by substituting r is equal to 7 into that formula, we get pi into 7 square, which is 49 pi millimeter square. D is our correct answer. And always remember to convert all units in the units that are given in your options, that is millimeter square in this case. 13. Which of the following molecules are involved in both aerobic and anaerobic respiration in healthy humans? So 1 is carbon dioxide, 2 glucose, 3 lactic acid. We know that in aerobic and anaerobic respiration both, we have glycolysis as the only common reaction, and there is no link reaction or Krebs cycle or oxidative phosphorylation in anaerobic respiration, which are mitochondrial reactions. And carbon dioxide is a byproduct of Krebs cycle, so it will not be present in anaerobic respiration. Glucose is a part of glycolysis, so it will be present in both aerobic and anaerobic respiration. Lactic acid is only a byproduct of anaerobic respiration, therefore our only option is option 2, and that is given in option B. So 13 is B. 14th, we have identified the correct products of electrolysis of the following electrolytes, electrolyte being electrolyzed, positive and negative electrode. We need to know that anodes attract anions and cathodes attract cations. This is basically the discharge series, and you need to know that hydroxide ions are discharged in preference to any other anion. Therefore, oxygen will be discharged in case of aqueous solutions. And here, aluminium can never be discharged. Chlorine can, but there is no hydrogen in the case of a molten sodium chloride. Therefore, the correct option is option C. Moving on to question 15, the diagram represents a satellite communication link between 2 points on Earth. The distances between the transmitting station, the satellite, and the receiving station are shown. The frequency of the waves used for the link can be taken as 1.5 into 10 to the power 10 hertz, and the speed of light as 3.0 into 10 to the power 8 meters per second. What type of wave is used in such a link, and what is the time delay between a signal being transmitted and then being received at the receiving station? So from the frequency and from the type of distance that this wave travels, it is obvious that it is a microwave. And to calculate the time delay, we must divide the total distance that it travels, that is 90,000 kilometers, or 9 into 10 to the power 7 meters, divided by 3 into 10 to the power 8 meters per second. That will give us the time delay, which is the time that it takes for to travel from transmitting station to receiving station. So 9 into 10 to the power 7 divided by 3 into 10 to the power 8 will give us 0.3 seconds. So the correct answer is option D, which gives microwave and 0.3 seconds as type of wave and time delay. Question 16, the diagram shows a quadrilateral. Given that tan theta is equal to 4 by 3, what is the area of the quadrilateral PQRS? So let's imagine that we create a perpendicular from Q to the line PS, and let's say it joins PS at a point called X. So QX is perpendicular to PS, and we know that PX is equal to 11 minus 5 centimeters because QR is equal to SX. So 11 minus 5 is equal to 6 centimeters for PX. And we know that tan theta is equal to QX divided by PX. So QX is equal to, QX is unknown, so QX divided by 6 is equal to 4 by 3. Solving for X, we get X is equal to 8. And therefore, using that, we can calculate the area. So half into PX into QX, which will be half into 8 into 6, which is 24. And to calculate the area of the rectangle, we have 5 times 8, so that's 40. 40 plus 24, that's 64 centimeters square.